Hello. The purpose of this mini lesson is to present the difference between a function and a relation. So we're going to make a couple of definitions. The first one is this, that a function has to have for each independent variable only one value of the dependent variable. Usually we talk about the independent variable as x and then the dependent variable as f of x, or the input and the output. So for every input, there is only one output, and that is the connection with a function. A relation is there may be a pattern between two sets, but there's no one-to-one relationship. We're going to do these via examples to clarify it. These are the definitions. So good, but what does it mean when we do math? Let's take a look at what it means when we do math. So we will need to be a bit of detective work. Come along and see, if necessary, pause the video at certain points and see if you can make a decision. So we're going to ask you to decide if what we show is a function that will be identified with the letter F in blue, or a relation that will be identified with the letter R in red. So let's take a look at this one. And of course, we are also going to look at different representations. So in this case, we have a description. The height of the students in this class. Would that be a function or would that be a relation? Well, when we think about it, each student is matched with one height. Therefore, this would be a function. This is something that is important. Let's say student A has a height of 180 centimeters and student C also has a height of 100 centimeters. That still makes a function. Even though they both have the same height, each of them is matched with only one height, which is 180. Here's another representation. We have a mapping here, and we can see the relationship between three. This is the domain and range, or the input and the output. 3 matches is mapped to 2, 2 to 4, -6 to -2, -1 to 1, and 0 also to 1. So would that make it a relation, or would it make it a function? Similarly to the previous example, this is a function because for every value in the domain, there's only one value in the range. Even though -2 and 0 both map to 1, each of them is only mapped to one value. So that makes it a function. Now, what about this one? Well, this is the equation for our basic quadratic function, y equals x squared, our parabola that we have studied before. And this definitely is a function because for every value of x, we have a value for our f of x or our y, right? We remember what it looks like. It's a parabola opening up. So for every x, there is an f of x. Very good. So far we've seen functions. What about this? This is an inverse of these, well, not inverse, a function that is connected to this one or looks similar to it. But in this case, instead of y equals x squared, we have x equals y squared. And if you can kind of imagine this, our parabola, the first equation, would be opening up. These would be opening sideways, like a C. So that means that for any x, I would have a value, say, above the x-axis and a value below the x-axis. So in that case, because of every input might have two outputs, this means that this is a relation. It's not a function. Okay, what about this? Y equals plus or minus the square root of x. Well, because we have the potential for a value that is positive and negative for the x, this makes this a relation, because we could have, if I put here 9 for x, the output would be plus or minus 3. Therefore, there's two possible values for the output. it cannot be a function. It is a relation. However, when I express it like this, y equals a square root of x, this means the positive square root. So these would be just the positive values. So in the same example that I just put before, if the x was 9, our output would be 3. Notice that it doesn't have the plus minus. So in this case, this is a function. And I hope you're beginning to see the difference between them. Okay, let's take a look at another case. This now is a table of values. Take a moment to look at it. On the independent variable, we have the numbers of week people work, and on the dependent variable is the amount they earn. So depending on how many weeks somebody works, this is how much money they earn. So take a look at it, explore it for a moment, and see if you can figure out if it's a function or if it's a relation. Okay, so if you notice, let's take a look at the first value of 10. Somebody worked 10 hours and earned $1,850. But we have a case of somebody else working 10 hours and making $1,400. So for the same input, we have two different outputs. So similarly with the 8, we have an input of 8 here and an output of 675 here and an output of 975. So for the same input, we have two outputs. That means this is not a function, it's a relation. So anytime two values of x associate with one value of x associates with two different values of y, or one value of the independent variable associates with two of the dependent variable, we do not have a function, we have a relation. Take a look at this set of ordered pairs and see if you can determine if this is a function or is a relation. Well, if you notice, the value for 0 here is paired with 6. So we have 0, 6, 1, 2, 2, 5, and then again we have 0, 5. So the 0 maps or is paired with the 6 and is paired with a 5. So because the same value cannot be associated with the two values of the output, this is a relation. Here it comes. All right. Now let's take a look at this. Now our domain is 0, 1, 2, and 9, or the values of our independent variable. And we notice that each of them is matched to a unique value. 0 is matched to 6, 1 to 2, 2 to 5, and 9 to 6. Notice that even though 0 maps to 6 or paired up with 6, and 9 maps up to 6, this is still a function because each of the independent values match to only one. Compare these to the one before. So you will see here 0, 6 and 9, 6 are part of the function. 0, 6, 0, 5 are not. So this arrangement is a function. So we have seen these representations, a description, a mapping, equations, and ordered pairs in sets. So what happens when we have a graph? Well, we're going to take a look at when we have a graph, and we have something that we call the vertical line test. And this helps us understand if something is a function or is a relation. So we have four graphs here, each of them representing a different situation. The equations for them are there as well. And what we mean by the vertical line test is this. It's a very visual way for us to understand if a graph represents a function or not. If I were to put a vertical line and sweep across any of these, I will know that it's a function if, when I sweep my line, my vertical line is only touching one point at any time. If my vertical line touches 2 points, that means that there are values in my independent variable that match two outputs of the dependent variable, and then I have a relationship. So let's take a look here at the first one. So what do you notice there? For the linear relation, these went through and it always touches 1 point. Now here, look at this equation. In this case, this vertical line is touching 2 points. For a certain x, there are two f of x. Therefore, this is a relation. This is a function. Let's examine the ones in the bottom. There we go. Take a look, although this was a bit quick. Similarly, here, we notice that our vertical line goes always touching 1 point on this graph. But when we come to this circle, the vertical line touches more often than not, it touches 2 points as it is doing now. So right now, we can determine that this is a relation. So these A and C are functions, B and D are relations. And that's it. We're going to do some exercises with this. And I hope this was useful. This will be posted as a slideshow on our Brightspace.